thank you very much. My name is Sean Fleming, and I am in the IoT unit within Nokia. It's a newly formed unit as part of the new Nokia. As you may or may not be aware, Nokia acquired Alcatel-Lucent not too long ago, so it was a probably big change for Nokia, and it brought in a huge portfolio of additional assets. So I am not a lifelong Nokia person. I come from a smaller software environment. So we're going to talk about today about enabling smart, safe, and sustainable cities. And first, a little background on Nokia. So we are a telecommunications expert. We've helped pioneer various technologies over the years. We were involved in shaping these various analog, digital, mobile revolutions that you see behind me. And now we're preparing on a new connectivity revolution in which everyone and every object will be connected through billions of sensors through the Internet of Things. The new Nokia, with our combined capabilities in innovation, research, and development, is ready to shape that revolution where our IoT solutions can be embedded in cities around the world. So I think one of the former speakers mentioned some statistics and numbers, and I would be remiss if I didn't include a few in regards to what we're seeing in cities and our various studies. Cities today occupy just 2% of the Earth's surface, yet they're home to more than half the people in the world. They consume roughly 3/4 of the world's energy and generate about 3/4 of its greenhouse emissions. By 2050, more than 2/3 of the population will live in cities. Urban areas are expected to absorb all the population growth expected over the next 4 decades, while drawing in some of the rural population as well. So in this context, governments are challenged to find responses to the growing urbanization rate, climate change, global competition, budget constraints, and the demand from citizens to actively participate in political decision-making. We've also entered into a new ultra-connected age. Broadband speed has increased 3 times since 2012. Every day, 100 terabytes of data are uploaded into Facebook. Every minute, 48 hours of video are uploaded into YouTube. And the implication of all these changes are new ways for people to interact and the new potential services for cities to offer. The Internet of Things in particular will have a huge impact, not just functionally, but also economically. By some estimates, city IoT applications could have an economic impact anywhere from $930 billion to $1.6 trillion per year in 2025. IoT transportation applications generate an economic value of more than $800 billion a year. In public health, IoT applications could yield about $700 billion per year, mainly from life-saving improvements to air and water quality. Using IoT smart meters to reduce the loss of electricity in distribution networks, or IoT sensors to detect leaks in water systems, could be worth as much as $69 billion a year globally. So this is part of the reason why Nokia has strategically focused on smart cities, created our unit to focus on addressing solutions there. We're focusing a bit on the platforms and applications as part of that, but we also have our great connectivity solutions as well. So the profound implications of global changes resulting from increased urban concentration requires new ways of operating, with new ideas, new knowledge, and new technologies. Of course, new infrastructure and applications only make a difference when they actually enrich people's lives. Responsive, flexible technology that works for humanity is what makes cities smart and creates a safer and sustainable environment. So what makes a city smart? Smart cities use advanced ICT and the Internet of Things to make people's lives more comfortable and convenient and deliver applications that support innovation, economic and social development, making cities more attractive places to visit, live, and do business. The availability of high quality and high speed fixed and mobile data connectivity allows cities to better communicate, interact, and innovate, making them more competitive and innovative. As evidenced by leading analysts, for every euro spent on broadband infrastructure, 14 euros can be generated by the local economy. And we see this evidence in various smart living type applications, such as public Wi-Fi, connected signage, event notifications, smart applications for tourism. It makes a city safe. So safe cities are going to use ICT and IoT technologies to prevent, or minimize the risk and impact of adverse events, including crime, accidents, environmental pollution, and natural disasters. Using advanced video and sound analytics and mobile edge computing, for example, could help emergency service agencies react faster and make better informed decisions about resource allocation. These technologies also greatly enhance situational awareness during a mission, both for the incident commanders and the first responders. With more sensors integrated into personal protective equipment and wearables, the safety of first responders is improved, while helping commanders make faster decisions in emergencies. We can also make city roads safer with technology. Road safety systems can be enhanced by tracking emergency vehicles in a way that's interconnected with smart streetlights. Connected car technology can notify drivers so they can more easily make space for emergency vehicles. And finally, different types of sensors with advanced analytics enable close monitoring of air quality, noise, pollen, water quality, and flood risk. And we're looking at some various smart city applications in the areas of crowd monitoring, road safety systems, emergency alerts and notifications, access control and perimeter surveillance, smart CCTV, and video orchestration. What makes a city sustainable? Sustainable city applications are intended to reduce the environmental impact of municipal operations, local business and everyday living, such as energy consumption and carbon emissions. IoT applications can reduce these impacts in part through applications that support the microgeneration and distribution of renewable energy and a modal shift from automobiles to other forms of transport. Applications like real-time multimodal traffic monitoring, IoT in urban transport vehicles, and smart parking, and smart lighting can all help better control, manage, and reduce the massive flow of cars in cities. Sustainability is also about selecting and adopting the right business models to fund, invest, and cost-effectively manage these smart innovations now and over the long run. So we mentioned a few of these types of applications, from smart parking, traffic management. There's also energy management in buildings, waste management, public water management as well. So what does it take to become a smart, safe, and sustainable city? Many minds and resources are needed to make cities smart. Success depends on involving citizens, government, industry, as we can see, academia, and other stakeholders throughout the process, from vision to implementation and planning. Engaging these citizens helps drive a people-centered transformation. Working with an ecosystem of trusted partners gives cities access to broad expertise and forward-thinking innovation while stimulating the local digital economy. Also, linking administrative services by sharing data and infrastructure, and we'll talk about how that's done in a moment, can enhance synergy, increase efficiency, and lower costs. Looking to the long term, the industry can help with public-private partnerships to secure ongoing financial resources so cities can operationalize and maintain smart, safe, sustainable living. So no cities are the same, and no implementations are the same. We've identified a few ways for cities to become smart, safe, and sustainable. It's basically identifying them as an anchor, taking the anchor approach, the platform approach, or the beta approach. The anchor approach is when a city is really focusing on a core application to build out and deploy, roll out, very focused, proves out the business model relatively quickly, and it's a shorter path to the whole ROI. Problem is, it can be harder to integrate applications in the future since we're so focused on a particular application. The platform approach was where cities focused on building on the network infrastructure or platform for smart applications before adopting any specific application themselves. This does allow for synergies between applications in the future, and it provides flexibility for future deployments, but the absence of mature standards can make specifications and making the choice of that platform or network infrastructure difficult, and you run the risk of vendor lock-in and significant upfront investment. And then there's the beta city, where cities experiment with multiple applications without a finalized plan for operational deployment. The goal is to get practical, hands-on experience with applications and technologies. This reflects the general reality that relatively few smart city applications are fully deployed, operational, costed, and budgeted. Most are pilots of varying degree of sophistication and scale. The beta city approach can enable easier access to funding for trials and research and facilitate greater involvement from startups and small innovative companies. However, if it proves successful, it can be difficult to move beyond that pilot phase to achieve full operational deployment. So what's the foundation of smart cities? Well, we think that foundation is tied into data. The centrality of data is a common theme across smart cities. Some cities collect and use their own data to build up their own applications and services. Others have taken more of a publishing approach, seeking to make available the data they generate or curate provided by others. And such data can be provided via open data portals or through a paid-for data marketplace. In both cases, the expectation is that third parties are better able to exploit the data than the city can itself. Creating a smart, safe city demands an adaptive, shareable platform, one that combines everything from the network that securely transports the data and services to the devices and applications that make up IoT. Such a platform needs to combine an open data approach for maximum interoperability, coupled with robust security. And I think we heard some mention about security mechanisms earlier. Security needs to protect people's data assets and keep city operations safe. And it also needs to scale, growing as the city becomes more connected and smarter, enabling new applications and services underway. From a shared perspective, the smart city is a complex ecosystem with many stakeholders. In order to maximize synergies and minimize costs, it's important that they do three things: share reliable IP broadband network infrastructure, applications and data over a single IP infrastructure, ensure that the application and service providers have access to a horizontal city platform with a common set of capabilities, and that residents have ubiquitous and real-time access to applications anytime and everywhere. From a security standpoint, security and data privacy are high on the agenda for any city. We need endpoint protection, data protection, device management, authorization, authentication, traffic profiling, and encryption. All of this is needed on a city checklist. And just like scalability, true security can only be achieved when possible threats are taken into consideration up front. And from a scale perspective, we expect that many city initiatives are going to start small, but they're going to grow fast and they're going to scale big. So this can only be achieved if the city has a platform infrastructure that is scalable by design. Nokia, we think, is uniquely positioned to help governments, municipalities, communication service providers, and large enterprises deliver on the promise of the smart city. Our portfolio delivers all the essential components of a shared, secure, sustainable smart city platform that ensures the best use of urban resources. Specifically, our multi-layered smart city framework provides the technological building blocks for enabling new smart city applications to be rapidly created, deployed, extended, and managed. These include citywide connectivity, a shared citywide network, a city cloud architecture, a city IoT platform, which manages all the things, sensors connected, and makes data available for third-party applications, and then various city applications, some of which Nokia can provide, and others come from trusted partners. Through our Smart Cities portfolio, we deliver the products, tools, services for city devices and sensors, citywide access, a city shared network for aggregation and backhauling of data and communication, city cloud architectures, IoT service creation, device connectivity and device management and connectivity platform, data collection, analytics, application enablement, as well as an ecosystem, all while addressing customer experience, security, scalability, and professional services. From an ecosystem perspective, high-value IoT and smart city applications get to the market faster when they're built through joint global efforts from innovators in infrastructure, devices, applications, and content. We work with an open ecosystem of trusted partners. We have a program called the CENGN Connect program that's enabled member companies to develop new products and services faster and with a high profile to customers. Today it's comprised of more than 300 members, including leading network, consumer electronics, applications, platforms, and content providers. The IoT community within the CENGN Connect program brings innovative companies together to collaborate on solution concepts, end-to-end prototypes, business models, market trials that will unleash the full potential of IoT. Through this collaboration, we are evaluating new business models for use cases and accelerating the delivery of IoT solutions and business value. We've launched this IoT community at this year's Mobile World Congress. It is currently up to about 100 members. We're adding on average 5 to 10 a month. And right now we target open collaboration around business models for application developers and device members. And through this collaboration, we can evaluate the models for various use cases, accelerate our own delivery. We recognize that Nokia alone can't build out all of these solutions. We need a strong ecosystem of partners. As you can see from the logos on the slide, they span a wide range of industries and markets and innovators from all domains. Nokia has identified that within the wide vertical spectrum of IoT, there's around 5 select areas that we think it makes sense for us to focus on, and smart cities is pretty key in this. A citywide IoT platform reduces costs and simplifies the collection, processing, and management of big data by remotely managing millions of connected devices and sensors. It provides the necessary layers for connectivity management, application enablement, device management that is secure across all endpoints and enables the effective use of data and analytics that will create value for a city. Fragmentation within the IoT industry, which is rooted in different devices, applications built on proprietary protocols, can stifle innovation. In the municipal space, the effects of this complex ecosystem are felt in integration cost, management complexity, and time to market for new applications. A horizontal platform, as indicated here, drives down the cost, but enables mass adoption of IoT applications as it ensures maximized value of analytics and managed data through end-to-end authentication, security, and privacy. It delivers value beyond connectivity through a richer experience and a set of services for customers. And it scales by applying platform functionality across all verticals without building discrete solutions for each vertical type application. Our Impact Platform provides horizontal services for all IoT applications and verticals. It is a horizontal platform that covers connectivity, data collection, analytics. It has multiple layers, data collection, fault monitoring, single domain for applications and networks and protocol agnostic design to accelerate faster time to market. It has a standards-based protocol for device communication that removes developer device management barriers. Has an API layer for extensible object model that allows flexible devices and use cases to be added to the system without programmatic type modification. Has high-level REST APIs to expose common IoT functions to reduce time to market and complexity of development standards, as well as a southbound integration layer. The platform is modular in its approach, aligned to mix and match services like device management or analytics, depending on what third-party components that may already be in use at a particular city or enterprise. Citywide connectivity means using optimal access technologies from fixed to mobile to connect all people, devices, and machines and sensors, and to provide administrative businesses and citizens the high-speed service that they expect wherever they are. Extending broadband coverage and capacity to every neighborhood and street improves the citizen experience. And by deploying smaller and more efficient equipment in urban environments, cities can also reduce their carbon footprint. Considering that IoT use cases are so diverse, the range of uses will almost be limitless. But not all IoT devices and applications will have the same connectivity requirements. Near zero latency can be vital for some, while others will tolerate a considerable delay. Some applications will send and receive large amounts of data, so high bandwidth will be essential. Others will have different mobility requirements or have varying reliability needs. One type of access does not fit all. The multitude of use cases translates into different network requirements, and therefore multiple networks are going to complement each other. Throughout our extensive mobile networks and small cells portfolio, we provide cellular and Wi-Fi coverage and capacity to outdoor and indoor locations across the city. This is mainly for applications requiring large data throughput and critical communications, such as in public safety. With standards-based licensed cellular technologies such as eCGSM, or narrowband IoT, and LTM, complemented with LoRa, we also provide low-power, wide-area capabilities for massive amounts of IoT devices and applications. Also, our IoT-optimized core includes packet core and subscription management, and offers solutions for reducing signaling traffic. Now, to support the diversity of use cases, it can require extreme broadband and ultra-robust, low-latency connectivity, massive networking for the Internet of Things. When 4G networks were primarily designed for the single use case of delivering high-speed mobile broadband, 5G is a new generation of radio systems and network architecture which will transform our individual lives, economy, and society. What 5G will be good for and what technical requirements that it imposes on the network have now become pretty clear. The industry seems to have widely adopted Nokia's view that 5G will be about people and things as per the following three categories of use cases. Massive broadband that delivers gigabytes of bandwidth on demand, critical machine-type communication that allows for immediate synchronous eye-hand feedback that enables remote control over machines, and massive machine-type communication that connects billions of sensors and machines. When you quantify some of those expected benefits, that's when the proposition for individuals, society, and the economy becomes exciting. Take autonomous driving. There are around 1.3 million deaths on the road each year, which is more than double the amount killed by malaria worldwide. There are also 50 million people injured in traffic accidents globally. Now, of course, you need the latency and response times to be instantaneous for these cars, which is a far cry from the 15 to 20 millisecond responses that today's best LTE networks are typically providing. But to put it another way, if driver error is the cause of 90% of all car crashes, and autonomous driving and connected cars are reduced in only 50% fewer annual fatalities, that would be more than 500,000 lives saved. And every year, more millions with fewer injuries. Consider the potential reduction in CO2 emissions. The pollution from transportation is expected to increase nearly sixfold. In China, for example, from 190 megatons every year to more than 1,100 megatons in 35 years' time. Connected cars, smart navigation, and autonomous driving can reduce millions of tons of CO2 and help cities become cleaner. We don't have to wait for 5G commercial availability, since the market for new 5G possibilities needs to be prepared. 4G is a key enabler for 5G and key LTE enhancements, such as carrier aggregation for more capacity, connectivity that is dedicated to cellular IoT, and advanced antenna systems for better customer experience, unlock new 5G-like services. So we can explore with you the new opportunities and use cases enabled by 5G, utilizing current technologies, and then evolving them in steps.